Hello, good day everyone. Okay, so in this video we will talk more about the greatest integer value as a follow-up to a previous video number 27, which introduced the idea of greatest integer function or greatest integer values. Okay, so for number one, we have if x is equal to the greatest integer value of 5 over 4 minus square root of 7, and y is the fractional part of 5 over 4 minus square root of 7, find the fractional part of 4x squared plus 9y. And in number 2, if x times the integer value, the greatest integer value of x is equal to 84, and y times the greatest integer value of y is 68, then find the expression greatest integer value of x times the greatest integer value of y minus the greatest integer value of x plus y. Okay, so let's go to number 1. So number 1. First we look at 5 over 4 minus the square root of 7. Just like before, we have to rationalize the denominator. So this is 5 times 4 plus the square root of 7. And this one is 16 minus 7. So this is 20 plus 5 square root of 7, yes, over 9. And we have to change 20 into a multiple of 9 and greater than 20. So the closest is 27. So let's change that to 27. So that is 27 plus 5 square root of 7 minus 7, because we already have a 20 over 9. So 27 divided by 9 is 3, so we have 3 plus the irrational part 5 square root of 7 minus 7 over 9. So we first verify whether the irrational part of this expression is less than 1 using the test that we have introduced in video number 27, and that is since 5 square root of 7 squared is equal to 25 times 7, which is 175, and 7 plus 9 squared equals 16 squared, which is 256, and 175 is less than 256. Then we have we are sure that the greatest integer value of 5 over 4 minus square root of 7 is equal to 3, and this is equal to x. This is equal to x. and y is equal to square root 5 square root of 7 minus 7 over 9, because this is the fractional part of 5 over 4 minus square root of 7. It follows that it follows that 4x squared plus 9y is equal to 4 times 3 squared plus 9 times 5 square root of 7 minus 7 over 9 equals 9 times 4 is 36 plus 5 square root of 7 minus 7 equals 29 plus 5 square root of 7, which is equal to which is equal to 29 plus 13 plus 5 square root of 7 minus 13, which is equal to 42 plus 5 square root of 7 minus 13. Therefore, so here we got this number 42, or we got the number 13. No? We add 13 and then subtract 13 because we are using the test that we have introduced in video number 27, which is that 5 from the fact that 5 square root of 7 squared is equal to 175, and 13 plus 1 squared, which is 14 squared, which is 196. So 175 is less than 196. So we have the greatest integer value of 4x squared plus 9y is equal to 42, and the fractional part of 4x squared plus 9y is equal to 5 square root of 7 minus 13. So we have this results. So now let's go to problem number 2. We have x times the greatest integer value of x is equal to 84, but this is less than x squared, which means that the greatest integer value of x squared must be 81, which means that the greatest integer value of x is 9. And therefore x is equal to 84 over the greatest integer value of x, which is 84 over 9, and this is equal to 9 plus 1/3. Therefore the greatest integer value of x is 9, and the fractional part of x is 1/3. Similarly, y times the greatest integer value of y equals 68, and this is less than y squared. Therefore y squared the greatest integer value of y squared must be 64, which gives us the greatest integer value of y is equal to 8, and therefore y is equal to 68 over the greatest integer value of y. So we have 68 over 8, so this is 8 plus 1/2. Therefore the fractional part of y is equal to 1/2. So therefore the greatest integer value of x times the greatest integer value of y minus not yet. Let's look for the greatest integer value of x plus y first. So x plus y we have x plus y equals 84 over 9. Y is 68 over 8, which is 9 plus 1/3 plus 8 and 1/2. So this is 17 plus 6, 3 plus 2. So this is 17 plus 5 over 6. Am I correct? Okay. So we have hence the greatest integer value of x times the greatest integer value of y minus the greatest integer value of x plus y equals the greatest integer value of x is 9, and then this is 8 minus 17, which is 72 minus 17, which is equal to 55. There's another expression that we have to find. The expression is, so I'll just add it, number 3, or here. Also find the greatest integer value of xy plus y times the fractional part of xy plus x. Okay, so that's an additional problem which we will solve here below. So we have xy plus y is equal to your x is $84 . over 9 which is the same as 28 over 3. Okay, this is 28 over 3 because this one here is equal to 28 over 3, and this one here also divided by 4 or divided by 2, this is 34 over 4. Yes, divided by 2, and this is equal to 17 over 2. So we can use these smaller numbers, this one and this, instead of the bigger numbers. So we have 17 plus 17 over 2. So the least common denominator is 6. So this is 28 times 17 plus 3 times 17 equals 17 times 31 over 6. So this is equal to 527 over 6, which is the same as 87 plus 5 over 6. Whereas the other one, xy plus x, this is 28 over 3 times 17 over 2 plus 28 over 3. So again, the least common denominator is 6. So this is 28 times 17 plus 28 times 2. So this is 6. This is 28 times 19, which is 532. Which is 266 over 3. Which is equal to 'So we have these two results. Therefore, xy plus y, greatest integer value, times the fractional part of xy plus x. Okay, xy plus y, the greatest integer value is 87, and the fractional part of xy plus x is 2/3, which is equal to 87 is divisible by 3. 29. This is 29 times 2 equals 58. So we have this result. For the additional problem. So again, that's it for this video. I hope you like our discussion today, and if you want more problems like this one, and maybe some other problems also that are worth your effort, then